I like to call this video the trouble with tone. And it really isn't technically a trouble with tone. It has to do with the limited range that you find on continuity test mode with digital multimeters. And I have two different multimeters here. I have a Klein and a Fluke, and I'm going to take measurements with the continuity test on each of these, and we'll see what happens. And it's a pretty interesting lesson to be learned from all this. So let's get started. Before we dive into our lab, I just have a couple notes I wanted to discuss a little bit. First of all, you have to understand when we are using continuity test mode, the power for the test is derived from the battery within your multimeter. And that means, among other things, you do not work on an energized circuit. So that's one of the things. And I wanted to note the test lead placement, and you can see the black lead is on the common port, and your red lead is in the volt ohm port, as it always is. And so that's the important placement on that. And I also want to mention that continuity tests are what I consider to be a binary test. We're either trying to prove that a circuit is conductive or it's not conductive, or that a switch is on or off. That's really what they're designed for. And the circuit or device under test must be de-energized, and it also must be electrically isolated from any other conductive path in order to make a continuity test and be accurate about it. And finally, anytime you do a continuity test, you want to make sure that your meter functions properly before you actually do the test. And I will do that when we start doing the test. So let me set up the lab and let's get started. We have both of our multimeters set up for continuity test mode, and I've got our tone board set up here. And I'm going to start with the lowest value resistance and work my way through, and I'll start with the Klein. But the first thing, like I mentioned previously, you want to check to make sure that your continuity test mode is working. So I'll touch the leads together, and when I do, I'm showing 0, and you can hear the tone. So our meter's functioning. Now I'll go on the 10 ohm resistor, and it tones. You can hear a tone. And you also see we're getting 10 ohms on display. Now the 47 ohm, we are getting a tone. It's showing 46 ohms. And now we'll move over to the 100 ohm resistor. And it quit toning. It no longer tones, but it does show us 100 ohms resistance value. And now finally we'll go to a 1.5K, which is 1500 ohm. And you can see we're getting nothing. We have been placed out of range. The range does not reach that high. So let's now take a look at the Klein and compare and see what happens with the Klein. And this one, the leads are not quite as long, so I'll go this way. So again, we want to test to make sure it's functioning. And you should be able to hear the tone on that, and you can see we've got a measurement. And so we'll go to the 10 ohm resistor. We have tone, and I'm showing 10 ohms. Now we'll go to the 47 ohm resistor. And as you can see, we've got a measurement, but there's no tone. The device stopped toning. And now we'll go to 100 ohms. We do get a resistance measurement, but again, it's not toning. And when we go up to the 1.5K, we have been placed out of range because the range is limited. Okay, now that we've seen this, let's get out of here and explore that a little bit. Okay, we're back with both of our digital multimeters, and I have our resistors here. And what you just witnessed is something you really need to understand. All of these test instruments have a limited range when it comes to continuity tests. And if you remember, they both stopped toning after a certain resistance value, and then when you get high enough, you go out of range because that range is so limited. And so I delved into the specs a little bit, and I found on the Klein meter, it says that the buzzer sounds if less than 30 ohms. If you get above 30 ohms, it quits toning, and you'll notice it also quit giving you resistance measurements at a certain point too. So that's something you need to be aware of. And then on the Klein, I didn't find a whole lot of information in the specs, but when I went online, I found one place that told me that this will quit toning at 30 ohms. But if you remember right, we actually did show, we did tone at 47 ohms. So I'm not sure exactly where it happens, but it does happen at some point. And I want to close by just reading a couple of things. First of all, as I just said, continuity test mode on these test instruments has a limited range, and we need to understand that. Continuity tests should not be used if you are seeking resistance values. If you're looking for resistance values, then you need to go into resistance measurement mode and not use continuity tests. And a lot of times when you're using continuity tests, you're really listening for the tone. That's the whole point of it, so that you don't have to be looking at your meter. So it's not valuable if you get to a resistance where you're not going to be toning. It's not that valuable. And then finally, know the limitations of your digital multimeter. If you can't find it in the specs, maybe you can experiment and see if you can figure out exactly where things stop working.